my part is to do the linear graph. So from this screen, you can see that this is the basic form of the linear graph, which is y equals to x. There's two types of translation: vertical translation and horizontal translation. Y equals to x plus 1 is the one in red. So you have to add all 1 unit to all y coordinates. The x coordinate still remains the same. For y equals to x minus 1, you have to subtract 1 unit from all y coordinates. The x coordinate remains the same. So it has to be in the form of y equals to fx plus k or y equals to fx minus k. This is for vertical translation. Horizontal translation is in the form of y equals to f x plus k in the bracket, or y equals to f x minus k in the bracket. Y equals to x plus 2 is the one in red. Subtract 2 units from all x coordinates, or you can say shift the graph 2 units to the left. The y coordinate remains the same. Y equals to x minus 2 means you have to add 2 units to all x coordinates. Shift the graph 2 units to the right, which is the one in blue. Then there's reflection. There's 3 types of reflection: y equals to negative fx, which means reflection across the x-axis. Y equals to f negative x means reflection of the graph across the y-axis. Y equals to negative f negative x means both y and x-axis, that's a reflection. This is an example of reflection across the y-axis and also the x-axis. Thank you.
So here is the quadratic function. The basic graph for quadratic function is function equals to x power of 2. Before we start, we need to change the quadratic equation into completing the square form, and the reference point for this graph is 0, 0. When we talk about shifting the graph, we write function equals to x power of 2 negative 2. That means the graph will be shifting downward by 2 units from 0, 0 to 0, negative 2. But when we write function equals to x power of 2 plus 2, that means the graph will be shifting upwards by 2 units from 0, 0 to 0, 2. When we talk about translation, the unit in the equation will be vice versa with the movement. For example, function bracket x minus 2 equals the bracket power of 2. That means the graph will translate to the right by 2 units from 0, 0 to 0. But for function x plus 2 in bracket power of 2, that means the graph will translate to the left by 2 units from 0, 0 to negative 2, 0. When we put negative in front of the equation, that means it will have a reflection. Function equals to negative x power of 2, it means that the graph will be reflected to the x-axis. But for the reference points, it will be the same, which is 0, 0. For example, function equals to x in bracket x negative 2, we close the brackets power of 2 plus 3. That means the graph will be reflected to the x-axis. The graph will translate to the right by 2 units, and the graph is shifting upwards by 3 units.
Okay, now the graph that we will explain about is a cubic graph. It is the basic form of the cubic graph. The highest power in the equation is 3. Okay, we continue with the horizontal translation, which means we need to translate the graph to the left or to the right. Okay, for this one, we can see the A value is inside the bracket with the power of 3, and also we have the sign positive, and here we have the negative sign. This sign determines the side that we want to translate the graph. When the sign is positive, we need to translate the graph to the left, and when the sign is negative, we need to translate the graph to the right, correspond to the value of A. Okay, now is the vertical translation. For the vertical translation, we need to shift the graph upward or downward. We can know that the difference here, the A value is not in the bracket like just now. Okay. When the sign is positive, it will shift upward, and when the sign is negative, it will shift downward. Okay, now we go to the reflection. Reflection, we have two types: reflect to the x-axis and also reflect to the y-axis. When the negative sign is at x only, We reflect the graph through y-axis, and when the negative is for the whole equation, we reflect the graph to x-axis. Okay, example of reflecting graph that is not in basic form. Here we have the purple color one. This graph already been translating upward and also to the left. After we reflect it through x-axis, because the negative sign is for the whole equation, we will get the black color one. And here we have the same purple graph, and then when we reflect it through y-axis, because the negative sign is at x, we will get the black color one. So here we can look at the difference between reflecting x-axis and also reflecting y-axis. At the middle one, here is the graph that we combine everything in one equation. We have the reflecting and also we have the translation part. So to do the equation is actually we need to follow step by step, do the shifting part first, and then we continue with the reflecting. Okay, here we have the cubic graph with three different real roots. The intercept is following the three roots that we get in the equation. This is the basic form of the equation, and then the intercept will follow the alpha, beta, and gamma. Okay, here is the cubic graph that has two same and one different real root. It only have two intercept, and also same the intercept will follow the root that we get from the equation. And the last one is for the cubic graph that only have one real root. This one is the basic form of the equation after we factor out. It only have one intercept, and the intercept is the root that we have. That's all from me. Thank you.
Hello, I'm Vicky, and now I'm going to explain the square root function graph. At first, I will show you the graph of the square root function. This graph can be defined as the fx equal to the square root of x, and the domain of this graph is x is greater or equal to 0, and the range of this graph is y is greater or equal to 0. There are two types of graph for the square root function. The first one is translation, and the translation divides into two. The first one is the graph will translate upwards or downwards from the basic graph, and this will be the equation. And the second one, the graph will translate to the left or right from the basic graph, and this will be the equation. Okay, now I'm going to show you the first example of the translation of graph. The first one is when I want to translate 2 units up from the basic graph. I assume that the red line graph is the basic graph, which is the y equal to the square root of x. The blue line graph represents after translating 2 units up from the basic graph. The second example is when I translate 3 units down from the basic graph. As usual, I assume that the red line graph as the basic graph and the blue line graph represent the graph after translating 3 units down from the basic graph. The third example is, as usual, the red line graph represent the basic graph and the green line graph represent after translating 3 units to the right. The fourth example is, as usual, I assume that the red line graph is the basic graph and the green line graph represent the graph after translating 2 units to the left. Okay, the second type of graph for the square root function is the reflection. There are three types. The first one, the basic graph reflect on the x-axis, the basic graph reflect on the y-axis, and also the basic graph reflect on the x-axis and y-axis. The first one is the base I'm going to show is the basic graph reflect on the x-axis. As usual, the red line graph represent the basic graph and the black line graph is the graph after reflecting the basic graph on the x-axis. And these two will be the equation. And the second graph is the basic graph reflect on the y-axis. As usual, red line graph is the basic graph and the black line graph is the graph after reflecting the basic graph on the y-axis. The third graph is, as usual, the red line graph is the basic graph and also blue line graph is the graph after reflecting the basic graph on the x-axis and y-axis. And at the end, I show you the summary of the reflection of graph. That's all from me. Thank you.